Students, in this particular video, we are going to learn the concept of magnetic field due to a circular current loop. Let us assume this is a circular current loop and current is flowing in this direction, in this loop. And the radius of this loop is small r. So now, if you take a small element dl, the direction of dl will be along the tangent to this particular loop. dl means is this elementary length. Now dl vector will be pointing in this direction, and r vector, the position vector of dl from point p where we want to find the magnetic field, is in this direction. So if you redraw it, so this is dl vector and this is r vector. Angle between them is 90 degree. So theta is equal to 90 degree. Now if we apply Biot-Savart law, so according to Biot-Savart law, we can say according to Biot-Savart law, the magnetic field at point P due to this current element, will be dB equal to mu naught by 4 pi I dl cross r upon r cube. Okay, so I dl cross r upon r cube. Now you know the cross product of two vector. If we have two vector a and b, and if we take the cross product of them, then we write magnitude of first vector, magnitude of second vector into sine theta, where theta is angle between these two vector. In this case, theta is 90 degree. So dB is equal to mu naught by 4 pi I dl r sine 90 degree r cube. 1 r will cancel. Sine 90 degree will be 1. So mu naught by 4 pi I dl sine 90 is 1 r square. And direction of magnetic field, if you want to write, let us write only magnitude. So direction, as I told you, by using right hand curl rule. So if you curl the fingers of your right hand from ideal vector towards r vector through angle 90 degree, then the thumb will point in the direction of cross at this point. Cross means what? Perpendicular to the plane and going inward. Okay. So likewise, my dear student, if you take another ideal element, again that will be tangential. So due to this ideal at this point P, position vector r, the magnetic field will be again in the same direction, that is perpendicular to the plane and inward. So now the point is, if you take another ideal vector, so for all the different ideal vector, the magnetic field at the center will be in the cross direction. So all the dv vectors are in same direction. So net magnetic field, if you want to get due to this circular current loop at the center, then we need to do the integration along this particular closed loop. So dB value, we need to add all the different dB value. Mu naught by 4 pi I dl by r square. So now the term which are constant we will take out 4 pi r square into integration of dl. Integration of dl. So if we add all the different dl parts of this circular loop, it will be L only. So mu naught I by 4 pi r square and integration of dl will be L. And L will be equal to 2 pi into r, that is the circumference of the circular loop. The total length will be equal to 2 pi r only. So we can keep the value b equal to mu naught I upon 4 pi r square into 2 pi r. So 1 r will cancel, pi will cancel, and 2 2 ja 4. So finally we are left with b equal to mu naught I, b is equal to mu naught, b is equal to mu naught I upon 2r. So this is the final result of magnetic field at the center of the circular loop. So if it is a single turn coil, then it's fine. And if it is containing n number of turns, so for n turns coil, magnetic field will be mu naught into capital N into I upon 2r. Only we need to multiply it by this n value. So this completes the expression of magnetic field at the center of a circular current loop, and that is equal to mu naught times of I upon 2r for single turn coil, and for n number of turns in the coil, the magnetic field at the center of the loop will be mu naught into n into I by 2r. So thank you.